Yeah, so the last stream I had started working on week 4, and I skipped over coin change because I had played with it before. And let's take a look at it really quickly here. I had submitted a bunch of failed submissions, compile error, wrong answer, wrong answer. This is back in October, so I don't remember too much about what I did, but I do remember that I was trying a naive approach. I think I can click on it and take a look at what I had. Yeah. So next you tell us what went wrong. So I'm going to add this to a test case. So what I was doing here was just trying to see, well, can we just use the largest coin and subtract that until we can't anymore. And then, so I start with the 419 coin here in this example, keep subtracting until we found we couldn't subtract anymore, and then go to the next largest coin and next largest, and that fails. Because you can actually end up subtracting too far with the largest coin, and then you won't be able to subtract with the other ones. So, right. So I'm going to add this as a test case, given this, but I think what we need to do is do like a recursive approach, and that's what I'm going to try today to see if a recursive approach does the trick. So let me just grab this text here and then read the problem, because I didn't read the problem yet. It's basically you're trying to see how many coins, minimum number of coins. So you're given an integer array coins representing coins of different denominations, and an integer amount representing the total amount of money. Return the fewest number of coins you need to make up that amount. If that amount of money cannot be made up by a combination of the coin, return -1. You may assume that you have an infinite number of each kind of coin. So yeah. Tester passing. And then we're going to add this guy here. And let me actually move this over so I can see if the tests are passing. If I do that, then I can just look up here to see if the tests are passing or not. All right, so this is number 322. Let's find out where that slots in here. 322 goes right here. So 0322 coin change. Oops. Coin CHANGE. Wow. Okay. Let's create the file and jump to it. And then we're going to copy this code here. Paste. And right now I'll just return -1 just to get it to build. Oh, right. I keep forgetting I have to say obstruct solution. All right, so that builds. We have 3 warnings. That's fine. Right, I wanted to come up with some sort of a recursive solution, and this doesn't lend itself to recursion, right? So I'll create a separate struct here, struct coin changer. Coin change. There we go. And then we can implement on that if we're given. We'll just take in this coins vec, right? Vec i32, impl coin change, and that way I can create a new one, right? Fn new coins vec i30. Oh, yeah, it's gonna Clippy's gonna complain if you put a vec. It prefers this self, and then we can just say self coins into. Right, that should build. Right, and what we can do here is just say let coin change is equal to coin change new coins, right, and return -1, and that still builds. Okay. So to do a recursive solution, we need a stopping condition. So let's create a min coins self and amount, and we're going to just return a count of how many coins we can do, and I'll just do -1 for now, so that I can change this cc.min coins. amount. Oh, that's right. So we got to pass the amount in. Oops. And then, of course, I put a semicolon there. There we go. Okay. So now we have this. Let's write our test. So I have one test already that I have in my copy buffer, my clipboard. Failed test. And it was this. Oh, I guess I copied that. All right, let's take a look again over here. Grab this, copy. I forgot I did that. All right, so this is basically, oh, it doesn't tell us what the answer is supposed to be. That's a shame. Last executed input. Let me hit submit again on it, and maybe it'll tell us expected output. Let's find out. Because there's no point in doing the test. Oh, it doesn't even build. Oh, did they change the... Oh, right. Huh. Why did it not... Okay, this came up with the wrong answer. Maybe I have to copy this. Let's do that. And then go here, and then go here, and then see what the wrong answer is. See if they give us what the correct expected output. Yeah, Matt says, I think it submitted the skeleton. Yeah. Output -1, expected 20. Perfect. Okay, so let's grab that as our expected. Oops. And then under actual, we say solution. Coin change. We'll just grab this as a vec. And then the amount is 6249. And right now that should fail because I'm always returning -1. Should also fail because I forgot the extra close bracket there. One fail. Okay. And then I want to put in these two examples. Oh, 3 examples. I have 3 examples here. All right, let's do that. EX1. The output should be 3. Let's do this. And we just have to change this. 1, 2, 5, and 11. And then example 2 should be -1. This is just 2. And we're expecting 3, and we can't do that. So our test should pass, right? Because we're always returning -1. And then finally, expected, oops, 0, 1, 0. Right, that's our stopping condition. Okay. So we'll say if amount is equal to 0, return 0. That's an easy recursive ending point, right? So now what we're trying to do is recursively search for the minimum number of coins we can use if we spend 1 coin. So we pick a coin to spend, right, by looping over them. And then if the coin we pick is less than the amount that's remaining, then what we can do is recursively call min coins and find out how many coins that takes. And if that's less than our current minimum number of coins, then we save that. So we can say is, I guess, let mut min coins is equal to I32 max. And then we can say if for I in self coins, if, and I should be it's a reference to an I32. So star I is greater than amount, continue. So we can't spend that coin. But now what we can say is let coin count is equal to self min coins of amount minus the coin we chose. plus the coin we just spent. So we're spending this coin here, right? And that's where we're adding it here. So subtracting it here, adding it here, so it all balances out. And then this will give us the number of coins it takes to generate that amount. And if coin count is less than the min coins, oh, yeah, we can just say min coins is equal to min coins dot min of coin count, which means we can combine these two lines, right? Let's just get it working first before we get too complex. And then at the end here, we're just going to return min coins. Now, I don't know if doing a recursive solution, star I, duh. We have two fails. The only thing I'm concerned about with the recursive solution is they give you a certain amount of execution time, and if you exceed that, then you fail the test. Attempt to add with overflow. Oh dear. So I guess it's on line 31. We're trying to add 1 to min coins. Min coins is, oh, because min coins is maxed out, yeah. We have to actually check if coin count is not equal to I32 max, which means we couldn't find a solution. If it's I32 max, then we do this. And keep going. No, that still fails. Oh, so we mustn't add 1 here. That's the problem. We got to add it here. Duh. All right. That makes more sense. It's taking a long time to run. See, this is what I was worried about, is that having a recursive solution might end up failing us. And this might be a situation where we're just, I don't have it right at all. Okay, let's kill that. Cargo run. Oh no, cargo test, and then I'll give it the coin change. EX2 still fails. Okay. It should be return. Oh, right. It needs to return -1 if it can't find a solution. All right. So that means we have to change this -1, and then this just is -1. Oop. If min coins is equal to I32 max, return -1, else min coins. Oops, I forgot the word else. All right, let's try that. All right, so now EX2 works fine. We do have this test failing, right? So all the examples work, but this test does not work, and it's taking a very long time. Matt says I'd probably do option and map. Yeah, we could do that. But this is a little frustrating that it's taking so long to come up with the min coins on this value, or in this version of it. But yeah, let's try implementing with option, since that's a little more rusty. We can say this none here, right? And for I in self coins, star I is a greater amount. We still do that. Then we can say if let sum self in coins amount minus star I, right? Then we have to destructure the min, right? If let sum min equal to min count coins, and then if cur count plus 1 is less than min count is sum cur count plus 1. Like that. And then if it's none, then we have to set it here too. Min count is equal to sum cur count plus 1. And then we just return min coins. I don't know why I kept saying min count, because I'm thinking of counts. Right? And I messed something up. Which one? No, it doesn't tell me which one here. And all these underlines don't make it easy to find, right? Oh, right here. Okay, it doesn't like that line. Oh, right. I want to return an option here. Which means I need to do a, for here, I need to be able to return one or the other. If let sum count is equal to this, then count, else -1. Still not good. Oh, oh, so this should be sum 0, right? All right, let's see if that helps. No, we still have like this infinite. Can I run the test with in release mode? Yeah, it's running it in release mode. But this test takes forever. We're looking for amount of 20. Why? Right. Let's grab all this. Paste that in here, and then I have to also paste in the top part. It's still running. So we're going to run out of time, basically. Yeah, time limit exceeded. And the last executed input was this. Oh, and it doesn't show us what the expected output was. Okay. But I think it was, oh, similar to this line, right? 125. All right. Matt says, I'd say it's looping. The sort you had in the previous solution was the right way. You mean without the none, or the version I did that failed? Was this submission back here, and where I sorted the coins and then went through them in order. Matt says it should be 20 for 125 and 100. Okay, we can add that as a test. 1A. Yeah, failed test has been running for over 60 seconds. I'm going to comment this test out just to see. Yeah. I wonder if there's something we could do here that'll... I can come up with an iterative solution. Maybe that would be a better approach. I was really hoping the recursive thing would work. But let's try this. Let's get rid of this and this. And let's try an iterative approach. And min coins self amount I32. And I32 if amount is equal to 0, return 0. So what we can do is we can create a change array. A back bang of I32 maxes of mount as use size. Oh. Yeah, I think I want 1 plus, because we're going to If we do this iteratively, we actually have to go all the way up to the amount value, right? Because I want to say for I in 1 dot dot equals amount. And then for each coin, self coins len, we're going to take a look at this array. If self coins of coin is less than or equal to the amount that we're dealing with in this array, then we're going to look up the value in the array of I minus self coins coin as usize, right? And that's how many we currently have for that value. And if this is not, if cur count is +1 is less than the amount, or the amount that we're looking at, then we want to set it. Change I as usize is equal to cur count +1. Right, so this is just a min. We can change this. Change of I as usize is equal to change I as usize dot min cur count +1. Right. So this will go through each entry here and then calculate how many coins for that amount. And then once we get to the amount that we're dealing with, that should give us the minimum. If change amount as usize is equal to I32 max, then we didn't find a solution. Otherwise, we're going to return it change amount as usize. Let's see if that works any better. Although now we have to store this whole vector. Nope, it doesn't like this. Oh, right, and now I change this. This just becomes this. I guess I have to bracket this. This shouldn't change. Oh, wait, what's going on down here? Okay, let's fix this one first. Oh, this should be semicolon. Oh, right. Like that. Okay, let's see if that helps. Matt says, I think I got an idea, but I don't really like it. I'm not liking this iterative version either, but let's see if it works. Nope. Test failed. All right, so now we get this overflow issue. Oh yeah, it's the same issue as before that I had before. Okay, duh. So I can't do this anyway. We'll have to say if cur count is not equal to I32 max, then do this. Right? Nope. So it couldn't find a solution for these guys. But at least they run to completion. All right. Oh, I see. Yeah. Change 0 equals 0. You gotta say for 0 coins. Yeah. All right. Let's try again. There we go. Okay. I was trying to think why that wouldn't work, but of course it wouldn't work if you don't initialize it. Okay. Let's try this as our solution. Let's go over here. Actually, what we can do is just replace this whole thing, right? Paste. And then I have to change this. I wish you could run Rust format on the submission. Okay, so that was accepted. Matt, if you have a solution somewhere up on GitHub or wherever, I'd love to see what you got. Because I'm not thrilled with this, but I mean, this kind of does the trick. And now I'm tempted to just move on. I would love this recursive version working. And maybe we should do the same thing here where we'd have none and some, although I think that would make this stuff harder to do. Because we'd have to, we'd have to if let this, we'd have to if let this, yeah. So I'm just using i32 max kind of as a cheat. Matt says I can try the idea I had. Yeah, give it a shot. Let me know how that goes. I'm gonna move on to the next one because this one is. Let's run Clippy. Bacon. Clippy. Git add source. Git commit -m. Problem 322 coin change. I'm glad I didn't get this on an interview question because the pressure of having an interview, I don't think I would be able to come up with this solution in an interview. It's a little more relaxing on stream to think of things. Okay. I'm going to check that one off. Done. All right, let's take a look at min stack.